Hi guys, today we are going to start chapter 4 about measures of variability. So in the previous chapter, we learned measures of central location or measures of non-central locations. Um, and the key idea is we learned the measure of central location because we need to summarize a lot of numbers into one so that we can compare different objects, different groups, right, to make the right choice. So let me put it this way. It may be a wrong decision, but I'm not certain it is. I cannot say it is a right decision, but at least we can make decisions easily. So decision making becomes easier when you think of a measure of central location. The average is the most common, most popular measure when you compare to different random variables. Okay, so that's that's the main idea what we learned in chapter 3. But one thing you have to be careful is I already told you in chapter 3 that the average can be misleading. Like for example, when there are outliers. Likewise, there are some, like, it is not a perfect measure. On average or a median are not perfect measures. But so that's because when you summarize the information into one number, you lose a lot of information, right? That's obvious. You cannot avoid that. So then what we are going to do is today we are going to learn another type of variable, another type of measures that complement the measures of central location, right? So the average loses a lot of information in summarizing the data. Then you can just use another measure that captures the information lost from the average. That is what we are going to do today. As you can clearly see, we are going to study measures of variability. So any textbook has this chapter. Okay, let me start with an example. So if you are interested if you have a little knowledge about investment, you must have heard about these two important assets. One is S&P 500 index. So that is this is a composite index, consists of 500 big companies, right? So that is typical measure that captures the market, overall market, right? On the other hand, 10-year Treasury note is it's a bond issued by the federal government. United States government backs up the bond. So in economics, we treat this Treasury note as the risk-free asset. So among all possible financial assets in the world, 10-year Treasury note is the safest asset in economics and in the analysis of financial market. Okay, this is the risk-free return. So I collected data. By the way, I collected data from Yahoo Finance. You can also collect data from Yahoo Finance when you search for the stocks or bond. Then they show you data from 1985 up to last month. So I collected data up to December 2022, and I calculated the return, the yield from S&P 500 and 10-year Treasury note. As you can see, this is average. So the average return from S&P 500, the stock market, is approximately 8.5% yearly, right? And the risk-free return is 4.8% yearly. So clearly, this is again the summary of two financial assets. So we summarized S&P 500 into one number, which is the expected return, the average return, And similarly, we summarized treasury note into one number, which is the average return. And then, if you are choosing an investment, then can you just say S&P 500 index is a better investment just because its expected return is greater? That is partially correct. It is true that everyone knows that stock market will give you a better return than bond, right? So that's like finance 101. However, also you know that it is not always true. If S&P 500 index is a better investment, then why banks buy treasury note? Why does it exist, right? So the answer is clear. Safe. Let me show you the graph over time from 1985 through 2022. So as you can see, the risk-free return was much higher. Government bond was nearly 10%, over nearly 12% in 1985, but it came down. It's diminished, like decreasing over time slowly, and it nearly hit zero right before the COVID outbreak. And then, as you see from the news, it spikes up again these days. Maybe it's now near 5% or so, maybe. Anyhow, this is it. So this is what we see, and the average is 4.8. So somewhere here in the past, like say 38 years, the average was somewhere here, right? On the other hand, so this is bond, but what happens to S&P 500? This is the graph, right? By the way, this is monthly return, annualized monthly return. So annualized monthly return is kind of like exaggerated because, say, in a certain month, you may see, say, minus 10%. That happens like when the COVID outbreak happened, on one day, the stock market fell like 30%, minus 30%. But if you annualize it, then you have to multiply, like say, minus 30% times 360 days, which is this. That's the annualized return, which is not realistic. Like it does not have that kind of event does not happen throughout the year. So it is usually exaggerated. So the maximum is 350%. So if what happened in a month keeps happening throughout a year, then that year's return would be 350. But of course, it fell down the month next to the previous one. Okay. Anyhow, so this is S&P 500. What you see here is the scale, different scale of the return. So S&P 500 just is volatile, much more volatile. Like it goes nearly to minus 100%, and if you're lucky, you may have like plus 350%. So, and its average is only 8%. So it's hard to see where the average is. Average is slightly over this line. By the way, in this graph, you see there are blue line, that is the treasury note, which is hidden behind S&P 500. It's like this. If you rescale the graph, so same graph. This is the treasury note yield. So if you want to see this, that you have to make the scale like this, 0 to 14. It moves only between 0 to 14, but to compare with S&P 500, you have to enlarge the scale from minus like 100 to plus 400. So this is the graph. So what I'm saying here is, now you see the risk, the volatility in the stock market compared with the risk-free asset. Okay, so that is the reason why treasury note still there's demand for treasury notes, right? People, banks, financial institutions need to minimize their risk, and to do that, to hedge their risk, they need to buy the treasury note. Okay, so this shows that uh, your decision is not only based on a measure of central location. There is another dimension you need to consider when you compare things, right? When you compare random variables. That is one of the important thing is this volatility. That's what we are going to study today. So let me summarize the idea. Measures of central location capture where observations are centered around, right? So observations are around a certain number, but it loses everything else. Like it only tells you the center, but it does not say anything about how far from the center or how it looks, the overall shape around the center. It only tells you the center of the shape of the distribution. So we usually use, if you can use another measure, that is usually a measure of variability to complement the measure of center. So the measure of variability captures how far observations are away from the center. The distance between an observation from the center is the key information contained in a measure of variability. Of course, these two are just two most important measures, but still they summarize the information, so they are not complete information, right? So the shape of the distribution could be weird, then these two numbers may not be enough to explain everything. However, still, we cannot bring all the numbers everywhere, so we cannot present all the numbers everywhere. So we need to summarize. Then these two are, in many examples, the most important measures. So they are complementing each other. They capture different aspects of the distribution. Okay, so here are examples, and measures of variability are pretty important in many examples. Like, for example, as you just saw, if you think about investment in finance, measure of variability is risk. So risk is important. The high risk, high return. So that shows the idea. We are interested in high return, which is the average, but at the same time, we have to worry about high risk, which means variability. Okay, and also measure variability of income is about income inequality. So we talk about GDP growth rate, right? So, but the GDP is basically kind of on average, GDP per capita, right? That is a kind of average, but also maybe equally important is the inequality, redistribution of the wealth, right? So these days we are worrying more about concentration of wealth. So then it is not explained by GDP growth rate. So we need another measure to capture the inequality. And if you use the variability in a microscopic way, then variability of manufacturing, right? So when you make say paper, say letter size paper, then it should be like 8.5 inches wide and 11 inches tall. But actually, if you measure the true length, true size, it could be slightly different depending on the manufacturing errors, right? In that case, what you want is you'd like to minimize the variability error, right? So in that case, you are going to measure the variability of the size to capture the precision of the manufacturing process, right? If the outcomes are variable, are different from one to another, then it's not precise. It's about precision, right? Okay, so I gave you some basic ideas and motivations to study measures of variability. And we are going to consider two different measures of variability. So it's kind of parallel to what we learned in chapter 3. In chapter 3, the main object was the average. But as an alternative, we considered median and, in more general, percentiles, right? So basically, there are two types of measures of central location, and we are going to borrow basically the same ideas from those measures to define a new measure of variability. First, we are going to use percentile-based measures. They are range and interquartile range. So I'm going to define them later. And another type is average-based, mean-based. So variance and standard deviations are measures of variability utilize the idea of calculating the mean, right? So I will define them and compare them in the next video. Okay, so I will start with range in the next video. Okay, see you in the next one. Bye.